Thank you, Charles, for the great introduction. I'm honored to be here and very excited about this talk. I'm hailing at the moment from the US, from Virginia. So I'm doing a visiting professorship over here. And there's a lot of excitement about this topic, obviously over here and in Europe and in Ireland, and everybody's talking about ChatGPT. And I hope this presentation, which is followed by a Q&A, very much explains how this works, demystifies it, maybe teases a few new ideas or thoughts, and generally looks at this from both a societal perspective, but also from a scientific perspective. I would consider myself a positive technologist. It's a bit of a mouthful, but I see these developments very positive. They challenge us as humans. They should be making us better, I would say. So I'm not so much in the camp of this is going to destroy millions of jobs or this is going to create all kinds of new problems. I think this is a good development, and hopefully in the Q&A we can talk about that a little bit more. Let's have a look first at what ChatGPT actually is. Most of you, I assume, have seen this interface already. This interface is what you find once you go to the ChatGPT website. It's a interface that is created by a company called OpenAI, a company that was founded by a very famous people, including Elon Musk, who's not involved anymore. And it's often referred to as ChatGPT 3, which is the third version of this language model. There's now a ChatGPT 4. But basically what it is, it's this, if you haven't seen it yet, it's this very simple interface with a command prompt underneath. And this command prompt allows you to ask questions, make statements, and also to have a dialogue with this interface. That's why we call it chatbot, because you can actually have a little chat with it. And then really interesting things happen. And we're going to look at a couple of hopefully also interesting for you examples where this thing works really well, where it doesn't work so well, where it does a bit of problematic things, and so forth. So first of all, the obvious thing is I just came in this morning and just asked it as a self-reference, what is ChatGPT? And then it comes back with this kind of blurb. And interesting is that this text is recreated every time. So it's not a database lookup. This is very important if you're not so much aware of or familiar with machine learning technologies, or this field which is known as natural language processing. And this field basically spans a lot of different areas. And this ChatGPT is a generative model, a generative language model, which means it generates language. And every time you type in a query, a question, conduct a dialogue, whatever it is you're doing with ChatGPT, it will create a new output. So this is every time fresh content, just as you could say as a human does it, because we don't typically, if you ask a human, what do you think about the political landscape of Ireland? And then you get an answer, and then you say, oh, could you repeat that, please? Then most likely the repeat will be a little bit different. So it's the same with this language model, with this technology. You'll get different responses. So it kind of says this about itself. And essentially in the last sentence, it says, I am an AI chatbot designed to carry out conversations with human, mimic natural human communication. And the mimic is the important part. All of this is a simulation. All of this is mimicking. All of this is statistics and maths. There's not really much more behind it, and we'll demystify that a bit as we move through the presentation. Being a bit more specific about this, obviously a lot of text. I'm not going to, don't worry, I'm not going to kill you with PowerPoint bullet points and so forth. But I think it's important just to get a few of these terms into context, put these into context. The word chat is clear. It's a chat bot, basically an automated chat interface. And GPT stands for generative, which is the language creation part, the generating language part. Generative. We have other technologies in NLP, such as summary. You can summarize text. Sentiment. You can which is a classification problem where you can basically say, okay, is this text written in a positive or in a negative way? So there's a lot of NLP areas which don't generate text. They analyze text. They classify text. But this is generative, so it creates text. creates human language, most of it in English, which is the pre-trained part. So it's trained with mostly English language. A lot of these NLP technologies, especially where also this comes from, is from the translation space. So that's a nice overlap. So you can train it into different language pairs, but ChatGPT is predominantly trained with English content. That means sucking up a lot of content out of the web, over 100 million pages, and using these to create statistical inference. And then a transformer, that's a concept we're going to look at further down in the presentation. The concept of a transformer is the big innovative part, where this ChatGPT basically evolves around, which comes out of a research paper that I'm going to show you in a minute. It's built on OpenAI technology, or OpenAI's GPT 3.5, GPT-4 language model. These are very large language models. When I use the word language model, it basically just means it's a big statistical model which allows a machine to understand what words typically come before, after a word. I have one example, for instance, further down. Is the cat on the, and then there's a blank, and then a machine would typically say, is the cat on the mat? So statistically, it would know that in most cases, in this kind of context, in this kind of sequence of word, is the cat on the mat comes at the end. It might be a different word, but in a lot of cases, that's what comes. And that's what a language model does. It has a statistical inference to guess or predict, is often a word used in this context as well, what the next word is in certain areas of the sentence. So when you see ChatGPT creating these sentences, it creates a statistical outcome, but it basically creates an output based on the statistical model that we call a language model. The technologies or the approaches used are known as supervised learning or supervised training, which means there are humans involved in this. We'll talk about this as well further down. It's not purely machine done. There's a lot of human feedback, a lot of human training necessary, a lot of human supervision necessary, and reinforced learning techniques. And the reinforced learning techniques are interesting in terms of how this technology uses machine learning techniques, how it kind of comes up with this model. The reinforced learning has a lot of human feedback in it again. It's an approach where the algorithm gets rewarded if it guesses the right words, the right dialogue outcomes, the right answers to certain questions. But keep in mind that a lot of that stuff was pre-trained or pre-created by humans. So we're looking at a technology that used a lot of human content to train these models. So it's not as simple as just sucking up the web with a massive web crawler and then pushing this into some kind of machine learning engine, and then voila, we have a beautiful language model. It's a lot more complicated than that. There's a lot of filtering. There's a lot of things that have to be taken out. There's a lot of need for fine-tuning, which also results in these policy optimization models. So a lot of complicated stuff in the background, very expensive stuff in the background that we don't really typically see or hear about. And we do hear about these dates. So it was released in November of 22, very recent, and it's from a societal point of view, it's really amazing how I'll just go back to this slide. Apologies. It's really amazing how quick this jumped up. We have over 100 million users within 2 months. That's quicker than TikTok, quicker than Facebook, quicker than any other technology that ever came up that you can sign up to. So it's the fastest growing technology in the history of humanity. It has a massive amount of attention, and it's sucked up a lot of money. There's numbers flying around that it cost over 100 million to develop the GPT-3 model. I think it was a lot more than 100 million. I'm not quite sure. There's also numbers flying around that Microsoft invested 20 billion. So I'm talking billions and millions now, 20 billion into OpenAI to integrate ChatGPT into Microsoft Office products and into Bing search. I think the integration into Microsoft Office might have even happened already. So that's really interesting, because we're looking at a tool which which really extends the productivity of writing emails, text, and all these kind of things. So Microsoft being very smart there, taking ChatGPT and putting it into this, but it's very expensive stuff. It's very expensive to develop. It's very expensive to use. So if you look at the date 2022, this is also the language model. So one of the challenges about the language model is it's not real time. So it's not like search, where if you search for a certain event and like what's happening in Dublin over the weekend or something like that, and you'll see like the recent kind of concerts and things, it can pick up these things. So it doesn't constantly crawl the web or kind of update its knowledge. The knowledge is outdated and always like a year or two old. So it's kind of it's a nice demo at the moment, but it lacks in a lot of areas. So if we look at the power it used for training, 285,000 CPU cores and over 100,000 GPUs, 400 gigabytes per second of network connectivity. So these numbers are astronomical. So in terms of money needed, if you've ever been involved with trying to train a model or kind of get a GPU off someone, even in Trinity, that problem is often up. We have a super cluster there, but I always have to kind of compete with colleagues to get even access to 2 GPUs, and here we're talking about over 10,000 of them. So the money invested into this very simple looking chat interface is astronomical, and there's numbers going around that even when we conduct a query, which means if we ask this technology a question, we get massive, like basically the output costs OpenAI somewhere between 8 and 20 cents. So if you have 100 million users that are bombarding this with queries, it's very easy to see how economically this becomes a challenge. So it's an amazing piece of technology, but it's very expensive. Now, why are we fascinated about this? I just speak about this for a few minutes. We're fascinated always, I guess I've been always fascinated, and I'm assuming you as well, always fascinated about computers talking to us. If a computer talks to us, that's always a big deal. We have Alexa that talks to us, we have Siri talks to us, Google Now, and so forth. It's not really a dialogue. So if I say to Alexa, if I ask Alexa a question, where should I go for dinner this evening? It's a bit difficult for it to answer that. Or if I feel a bit under the weather, it might also not react very well to that, or wouldn't know how to help me. But like already in 1966, Joseph Weizenbaum, one of the pioneers of computer science and also AI, he wrote a system called ELIZA, and it was very famous at the time. But that just used database lookup. So basically, we ask a question, it would use pattern matching, and then it would try to get answers out of a database. But even then, it was a sensation, and we were really interested in it. So these stories, these chat interfaces, they go back really far. Always been amazing and sensational. And we can see where this goes. ChatGPT now talking to us in terms of text. Eventually, as it evolves, it will turn into human spoken language. Speech AI is a big thing, that you can have it speak in different tones, in your tone, maybe a tone of a famous actor, and it will then output a dialogue. And then we actually have a human dialogue with potentially a robot, an interface, and Amazon, and so forth. This goes back to a man again called Alan Turing, which is again something where I guess we all have been fascinated about. So Alan Turing, definitely one of the main pioneers of AI and this kind of way of rational thinking around AI. And he wrote this paper, can computers think, basically, can machines think? You kind of see that down there. It's a fascinating paper written in the 50s. And he came up with the concept of a Turing test. Does a human know that the response that comes out of a query, not knowing who's behind the query, basically like with ChatGPT, I don't know. I know that ChatGPT is a computer created response, but OpenAI could fool me and could have one of the engineers sitting behind the box, and I wouldn't know that. And most of these chat interfaces now pass the Turing test. It is very hard for us as a human to distinguish, is the answer from a human or is it from a machine? And if we can't distinguish, or if we actually think it's from a human, but it is actually from a machine, then that passes the Turing test. So one of the big milestones of AI that Alan Turing brought up is kind of ticked off. But the big question now, that nobody's talking about the Turing test anymore, even though it's significant and relevant, and we still have movies about it, and amazing kind of papers are still written about it. But we get into this discussion about narrow AI and general AI, and this artificial general AI which is what it's referred to, is a lot in the press at the moment, also referred to singularity or the alignment problem. So there's a lot of these kind of bigger concept and theories that are floating around now. And my research and most of my work in AI, or what I see in the domain of research, is still narrow AI. It's AI that is related to a specific task, such as having a dialogue, such as creating text, such as classifying text, such as creating an image, such as classifying an image, is it a cat or a dog, and so forth. So very specific narrow AI. Self-driving car, identifying if it's an object that is dangerous or harmful, identifying if it's a human or just a cardboard box. All those are narrow tasks. But now we're talking about, okay, because of ChatGPT, are we looking at general AI? So we're looking at an AI approach where multiple tasks can be conducted at the same time, which is bringing us closer to what a human brain is, or what we believe a human brain is. So these are interesting discussions. I just want to kind of throw that out there to tease your mind, and also just to put this into context. I personally don't believe we're anywhere close to general AI or super AI as the next level after general AI is often referred to. But it's an interesting thing to think about, and also to think about how can we come to this, keeping in mind that at the moment, the field of AI, or the AI that I'm aware of, is basically just data and a lot of computer power. So it's just data and a lot of computer power. So just by having more computer power and more data, I don't think that gives us general AI. So there's some fundamental approaches that might have to change. And that's a whole different discussion, obviously. But the hope that by feeding a lot more data into a lot more computers will give us a lot more intelligence, I think that's a little bit ill-founded, but that's just my personal opinion. The big shift that happened around this, and I think that's important also from you as an audience, from an engineering point of view. I grew up with so-called knowledge systems. Knowledge systems are rule-based systems. So if you think of an ATM, I put my credit card into an ATM, and I put in a PIN, and then I take 500 euros out or something like that. And if I then go to a different country, like I am now in a different country, the ATM might have a set of rules. The bank would have a set of rules to say, okay, is this actually Kevin trying to take out some money, or is it someone who stole his credit card? And those rules are like massive, and rule engines have still a big space in computer science, and definitely in computers. Typical database lookups, if then else clauses, rule engines are everywhere. But the shift happened very subtle, I would say, even in my research in the last 10 years, where suddenly nobody talked about rule engines anymore. Everybody talked about machine learning. And machine learning is statistics. That's a little bit different, a little bit more like the human brain, a little bit more fuzzy. So it's not black and white. It's not, okay, if I put my credit card in, it's either fraud, like it's a fraud kind of interaction or not. With machine learning, we get probabilities. It's like a certain percentage where, okay, there's a certain likelihood that this image is a cat or a dog. It's not black and white. A rule engine would always kind of go, okay, this is a dog, yes, or no, this isn't a dog. And it would have to have exactly the properties of that image that is in the database. With machine learning, we can do it a lot more fuzzy. We can create probabilities. We can create a much kind of a wider scope in understanding what is happening in reality. And the reason why that happened, that shift, I believe, is we got a lot more computer power. These GPUs, they got cheap and readily available. And then now we got a lot of information. So that's all that really happened, that instead of spending loads of time in creating rules, the machine, like the human creates rules in a rule engine, but now in machine learning, it's the machine that creates the rules and all the data comes in. So it's kind of flipped on its head. But now we don't have to spend a lot of time anymore in creating rules. The machine learning engine can infer the rules, create the rules based on the concepts and the correlations in the data. So it's an interesting shift. It's not often spoken about. It's a very kind of an engineering background kind of thing, but I think it's also important to keep that in context, that we do have this now. Nobody really talks about rule engines anymore. Everybody talks about machine learning. Very different concepts, but both kind of try to solve the same thing. So good thing, what does it do? It does, like the title of this talk basically says, it does amazing things around it does amazing things around creating stories in a certain style. So write a short story about a cat in a hat in the style of old Irish folklore, and it actually does a lovely job at doing this. So it's really nice to read this. Despite his antics, the people of Ireland couldn't but were enchanted by the cat in the hat and so forth. So it really creates an amazing job in this, and we'll have a little bit of a look how that works. but it also does things that are not so good. Okay, let's have a look at what the 3 things that the Vikings loved about Ireland. Obviously, that's raiding and plundering. Okay, trading opportunities, culture and references. So that doesn't really give me. It's very high level. So it's really good at creating stories. But as soon as we come to facts, to historical facts, as soon as we try to kind of dig a bit deeper, it just gets a little bit, I would say, boring and not really interesting. Obvious things come up, and it doesn't really go far. And if we go even to the ugly, let's say, okay, what did the British like about Ireland? It pretty much goes into like general thing. It doesn't really ask me a question back. Like it kind of assumes I'm going back to colonial Britain. It doesn't kind of say, okay, are you talking about Britain in the last 10 years? Are you talking about the North? What exactly is happening? So it's very, very high level kind of stuff, very kind of safe content. And that obviously is a massive limitation. So in terms of using this to create an essay about the history of Ireland, it might inspire, but it definitely will never replace, at least not the way it's designed at the moment. The way it's trained, so we'll just spend a few minutes in going into the nitty gritty. Obviously, this an entire term. So I would usually teach NLP an entire term just about this. So I kind of have to kind of keep it in a nutshell. But all of this stuff is basic. Just this slide is an entire term in a college. So it's a lot of stuff here. But what we're looking at in terms of reinforced learning is it's a very straightforward kind of approach. So you take content, dialogue snippets, let's say Reddit, any blogs, anything you can find, and then what you then take is you take away a couple of parts of this sentence. So again, if we take the cat is on the mat, if we take away the word mat, we kind of mask that word map, which means we kind of leave it out, and then we reward the model if it guesses the right word. So it basically gets trained on guessing. It constantly guesses against a trained data set, or basically a validation data set. So it basically keeps guessing the words in the masked gaps. And once it guesses the right word, or contextually right words, it gets a higher score. And these higher scores are then calculated into weights, or basically translated into weights, which create parameters in the model. And then when sentences come up or questions come up, it can go into the statistical model, and it will know how good it was trained. It will know basically based on this reinforcement how well it has done, and how well the output is. So it's basically like training a dog, if you want to call it that. If it does something good, it gets a cookie. So we're basically feeding it cookies based on guessing the right words in sequences. So that's really in a nutshell, and obviously that's super simplified, but just to kind of give you the idea how it works, and that works amazing for fairy tales. Again, if I just ask it to write a 10-line story of a cat in a hat in the style of oldish folklore, as if Shakespeare wrote it, it actually comes up with rhyme, fair and foul weather. Like if you're into Shakespeare, this sounds to me like Shakespeare. And then if you're into Samuel Beckett, you do the same thing, and you give it it gives you the same kind of idea, the same kind of idea of a story in the style of Samuel Beckett, which is a little bit different. It's not as grim as I hoped it would be. I mean, this is still a little bit too happy in my sense. I think Beckett would maybe do it a bit more existential, but it's interesting how this is done, obviously, because it has all the data, all the Beckett plays, all the Shakespeare plays in its database, and it was trained by reinforcement learning to understand what word pairings come, what words come after the next, and done that by being rewarded in doing so. So these are rewarded outputs based on the trained data. Now the dialogues are pretty interesting, and this is where I would say the cool stuff is happening, and this is where it's way more advanced than Amazon, Siri, Google Now, and any of those chat interfaces you're maybe aware of. So which is actually true, my parents are coming to visit, and I'm over here in the States at the moment. So if I go, my parents are going to visit tomorrow, what is the weather going to be? So first of all, it asks me, where am I? So a dialogue appears, and I say, I am in Emory, Virginia. And it says, okay, based on Emory, Virginia, this is the weather at the moment. So it kind of has this kind of information. I don't know how up to date it is. So it just says in March. So it's kind of like, it doesn't kind of say, it doesn't give me an up-to-date output, but that's beside the point here. The interesting point is on the next slide, where I then continue the dialogue, and I say, okay, will they need warm clothes? And then the dialogue remembers And this is this referencing technology. So the terminology around this and a lot of research around this is referencing. So it understands, if I say, will they need warm clothes? It understands that they refers to my parents. Based on the context and based on understanding what attention I'm giving in this sentence. So they refers to parents because in the language model, in the trained language model, it understands that specific the specific property of the word they refers to something in the sentence before that, again, is a noun or could be a specific linguistic property that it can point to, because in the trained data, it was very similar. So that's kind of how it figures this out. And it does this really well, this referencing, because if I continue the dialogue and I say, okay, does it need warm clothes? And it says, and then it gives me some kind of ideas, and I say, which ones? Then it knows that ones refers to clothes. And it says, okay, warm clothing or cold clothing. I don't think the answer is that useful. I mean, it's again very general and very kind of high level kind of stuff. But the referencing is an amazing thing in ChatGPT, that this kind of technology was integrated so well, and also that it works, that it really understands the contextual attention given in a sentence and understands what these individual words are pointing towards or what they are referencing. It's really bad at things that have to be specific. For instance, if you ask it about a treatment plan, in this example, I asked it about a treatment plan, pulmonary edema, so kind of a very specific kind of thing, and it just comes out with really obvious things. So it's very bad in anything that has to be specific. It's definitely very bad in medical stuff. Also, legally, ChatGPT cannot use any medical data. Obviously, there's privacy concerns there, but there's a huge interest and scope in that area. So how does this prediction model work? We'll just spend 2-3 minutes there and then round it up already at the end of this. So how does it know how this next word appears? So how does we know now that there's reinforced learning? We know that there's a lot of human in the loop, but how does it actually do it? It does this prediction model by obviously creating weights. So you have a neural network, basically a deep neural network, and this deep neural network has different layers, so it has different parts. Each layer represents the next word, for instance, in this example, and then statistically it understands based on these word pairings what word should come next. So that's a very, very simple way of looking at it, and it masks this. This is what I was saying earlier. It basically, if we have the sentence on the left, the chef cooked the meal, so that would be trained data, and then we mask the and cooked. And then the model would start guessing words based on the knowledge it already has. And the closer it comes to the word the and cooked, the higher the score and the more it gets a weight for those outcomes. This whole area, which is really interesting, this whole kind of, let's say, evolution of natural language processing in generative models comes out of a paper called "Attention is All You Need." It's a paper, as you can see, written by Google, and Google wrote an amazing paper about this, on which most of ChatGPT or GPT-3 is built. So Google kind of provided a lot of kind of knowledge into something that Google has no ownership over, but that's kind of nice because obviously this was a research paper, and that's how we kind of get this this output. And attention, and this is kind of the last more complicated concept I just want to introduce. And again, this spans usually multiple classes in a term. But basically, what we're looking at here is, how does a computer know what the context is? How does it know how to build these sentences that really kind of sound good and that really kind of come out in a really clean and in a nice way and really make sense in the context of the question, in the context of the dialogue? And it knows this by creating this so-called attention. So if we look at this this kind of swiggle on the left, but also the image on the right side, it knows that the word rabbit in most of its trained data is very closely related to hopped, quickly, or again, the word rabbit, but not so much to the words turtle or slowly or crawled. So by creating these word nets, you could almost call them, or these attention networks, the the language model can understand what words are related to each other, which doesn't really mean it understands what it is in the real world. It doesn't really know a rabbit is hopping and a rabbit has a kind of an existence in the real world. It just knows that a rabbit lives within different words. So the world of a machine learning engine like this, an NLP engine, is it lives in a certain context of words. It doesn't live in kind of a reality context, but it just knows context based on words that are close by. And the big deal that came out with this paper is where these encoders and decoders are used. So an encoder is taking the sentence and transforming it into something that the machine, into a mathematical representation that the machine can work with. And then decoder is creating a sentence based on this encoded question or language. And the big deal that came out with this paper is to use a lot of encoders and decoders at the same time. And encoders and decoders at the same time means that within training and within creating a response, not just the next word is being looked up. So it's not just, are you free? And then tomorrow, understanding tomorrow, and then creating a sentence, yes, what's up, basically, and as an outcome of that sentence, and not just guessing the next word, but understanding spanning. And this is really hard to imagine. And I'm still struggling to find a better way to kind of grasp this in the mind and explain this but to look at the statistical word pairings way beyond just what's before and after it, looking at entire sentences, look at entire sequences of text. So what we're basically doing is, it's like someone who's a little bit blindsided and can typically, in the old way, the prediction would, like if you use Google search, it always predicts the next word. So what weather is it in? And then it would say Dublin is the next kind of guessed word. So it's kind of very blind, like a horse with blinds on the side, and just kind of looks at the next word. But now suddenly the blinds are opening because we have a lot more computer power and approaches like these transformers, encoder decoder transformers, where suddenly we're opening our view and we're saying, okay, look at the 2 words before it and the 2 words after, the 4 words before it and the 4 words after, look at the sentence before and the sentence after. So the statistical reference model gets a lot bigger, and multiply that by 1 million documents and hundreds of million sentences. The machine learning algorithm and the machine learning language the model, that the language model becomes massive, and it has and its prediction space becomes much bigger, and with that a lot more accurate as well. So these are just basically different ways of looking at this. I won't go I'm going to provide these slides, so if you want to look at this more in detail, these are these different things. But the big deal, if you just want to see it from a scientific perspective, are these encoder decoders, attention mechanism transformers introduced by this paper that really widens the predictability space of these language models. A lot of human in the loop. We're coming to the end now, just another 2 minutes. A lot of human in the loop to kind of to train this, to filter this. So just keep in mind that it's not a magical tool that you just feed with a lot of content. There's so much human intervention needed that it's mind-blogging, but still obviously interesting nonetheless. So in a nutshell, it's often referred to as a statistical parrot. There's an interesting paper by Professor Bender, how language models actually work. Some people think it's a statistical parrot. Some even think that's insulting a parrot, because a parrot is even more than this thing. So it's pure statistics. It's pure maths. It creates amazing sounding outputs, but it's just sophisticated maths. I always say AI is statistics on steroids. But it's important to keep that in mind. It's not much more than that, at least not at the moment. It's still impressive. So if we just finish this in a more social context, humans have a different way of learning and speaking. We have a reference model or a connection to the real world. That's very different. So this language models only have a connection to language models. Apologies about the noise in the background. Only have a reference to the language, to the words that happen in a context, but not to what is actually happening outside. Language models are inward looking, so it's very disconnected to the outside, and it can't really observe anything. So there's a real, an obvious interface there, but that's why I also think that we're far away from general AI or super AI, because there's just this missing link to the real world and the real world understanding. I won't go through all of this, but is ChatGPT safe? There's no references given, so we never know where this text comes from. There's no explainable AI. We don't know how it's been generated. There's massive corporate investment, 20 billion by Microsoft, so it's for profit. It's not a non-for-profit company. Nobody sees the code, nobody sees the data, nobody sees how it's been done. It focuses mostly on English. Data set is a bit old, copyright and so forth. Again, in the Q&A, we can look at some of these, but it's a lot of work to keep this safe, obviously. It does mistakes. So how many female presidents did we have in Ireland? Did Ireland have? It says 1. So Madame McAleese, I'm sure she'd be a bit annoyed about this. So this kind of a bit of a bad answer, but it even does the same in America. It kind of says didn't have a female president, but in the next sentence it says that Kamala Harris was the first female vice president. But that's actually correct. It says it was the first female vice president, so it did a good job there. They fix it all the time. There's been examples on the web where it did the wrong thing in America, but it's still wrong in Ireland. So that's kind of an interesting aspect there. Will it replace search? I don't think so, because we don't have the references. When I use search, obviously for me, most important is where does this information come from? So it's a reference model search, obviously, and I can see, okay, if I have a certain information aspect I want to address in search or I'm looking for, then I know Wikipedia is something specific, or I go to the Financial Times or whatever it links me to. But in ChatGPT, on these outputs of ChatGPT, I don't know where the references are coming from. I don't know where the text comes from. I have none of this information. So I don't think anytime soon it will replace search. It might assist it, it might build on it. Where is it bad? It's only 2 more slides left. Where is it bad? It's really bad at calculating, very bad at qualifying, very bad at humor, sarcasm, irony. Like if we say something like, hey, there's a typo there, but if a waiter says, okay, that ham sandwich over there wants a coffee, because it's kind of a guest that's eating a ham sandwich. Obviously, I don't think the chat interface will ever understand that it's an ironic or a humorous way of referring to a human as a ham sandwich. So there's kind of these really funny examples floating around. Really bad at calculus, if we can't even add or summate, but then it's really good at coding. It can create amazing code, even entire applications in all kinds of different languages in really kind of fast ways. So it's amazing for that kind of thing, but also limited, obviously. ChatGPT is out. It's more, it has more human responses. It's better at solving tests. But the big one here is it's multimodal. It also does image processing, image generation kind of stuff, which is really interesting. So it's beyond text at this point. So overall, it's remarkable in creating fluent text. It's a great linguistic machine. It's amazing actually in linguistics, really inspiring. It confabulates a lot of things and makes stuff up, obviously, but it's still beautiful to kind of see how nicely it works. It doesn't provide any sources, and it's not a world model. It's a language model. So keeping that in mind, and the language changes all the time because our world changes all the time. There's questionable ethics and legals. And in the corner, just to finish with this, I have Prometheus, obviously, who gave us fire to his own downfall, but that's a different story. But in my mind, these things are tools, such as computers are tools, machine learning are tools. They're meant to help us humans, to help us make our world easier, better. And they're not made, and I don't see any massive way how it could replace things or how it could replace us. It's definitely an amazing tool, but we have to be aware of the dangers of a tool. Just as a knife can be used to create amazing food, it can also harm someone if we choose to do so. And it's exactly the same with these more advanced tools, which we call AI or ChatGPT and so forth. So that's it. Thank you very much. And I'm looking forward to your questions.
Thank you very much, Kevin, for your very interesting talk. I had a distant relative who worked in Bletchley Park, and she would have really enjoyed your talk today, because she worked on what we in Ireland call during the Second Emergency, or the Second World War. She worked in Bletchley Park, so she would have been fascinated and coming up with infinitely better questions than I could ever ask you.
Thank you.
Right, we've got a few questions, some of which has overlapped on your as part of your lecture, but I'll just kind of quickly run through them, and we'll try and keep this as relevant as possible. I've answered offline the question: is ChatGPT 3 being used to generate your answers in this? And I already answered that as no.
Yeah. That's a good question. Yeah.
It is a good question, but I answered it and I said no. Anyway, I'll just identify by the person from NOLA. Given the amount of computing time involved, as seen in the slide of GPUs and previous studies indicating the carbon impact of training transformer models, can we assume GPT-3.4 has significantly increased this impact? So how much carbon, how much processor cycles, how much power, how much cooling?
Yeah, I would say it has. There's a huge debate around sustainability with these technologies, and also that is a limit of this technology. So if as this technology goes into mainstream, into Microsoft applications, will be used a lot wider and potentially trained more on real-time data, and this will become a massive problem. So I'm always a bit surprised that this fascination about this technology is not so much balanced in the impact on energy and energy it needs and carbon footprint, and there's a lot of debate about that, and there's a lot of challenges in that area. Definitely, yeah.
Okay. Now, how does the AI break down and interpret the user's input into something that is used to build the answer? I think you've covered that pretty well so far.
Yeah, just to kind of give another context on that, the dialogue, because the dialogue is, for me at least, the fascinating part in this entire ChatGPT interface. And I invite you to try it, because it really is very good and it goes into interesting directions. But on the flip side, a lot of the dialogue outputs are human trained. So we don't know exactly how much of that is. OpenAI is very, very silent about it, but we know that massive amounts of human power has gone into that, where humans are basically just kind of they see questions coming up and then they would answer it as a human and then put it into the reference model, into the machine reference model to create the prediction model. But there's a lot of human kind of in the loop in these Q&A and these question answer kind of things that ChatGPT does.
Okay, great. I think that the next one is ChatGPT seems to create non-existent references and sources. Can present-day AI be made to use real technical references? And again, I think you've already answered that in the previous slide, where it will not reveal its workings in the background.
Yeah, but in fairness, and this is not to defend OpenAI or this kind of non-for-profit company, it's very hard. Like this whole area of explainable AI is bubbling up a lot. So basically, the need for us as society to understand how did the AI come up with this output or even with this decision. It's a much more pressing kind of need in self-driving cars. If a self-driving car causes an accident, it's very hard to reverse engineer what decision, but like what did the self-driving car what data did the self-driving car use to make a decision to take a right or left and or to avoid an object or go over it or whatever it is, because there's so much the statistical models are so complex and so finely integrated that it's very, very hard to kind of just open it up and say, okay, how was that decision made, that this kind of outcome, where did this kind of output come from? Some people actually refer to it as it's like opening a human brain to figure out why the human said something 2 minutes ago that was XYZ. So I would point to this research field called Explainable AI, and it's very hard to explain how these outputs get generated, because they're based on such a vast amount of statistical referencing that it's impossible to say, okay, it's based on this reference, or it's a bit of that, it's a bit of that. It's super complicated. Even if that would be provided, it would be very, very complicated to visualize or communicate.
Okay, great. From Kieran, you mentioned earlier that an AI model is trained by rewarding it when it guesses the correct answer. How can you reward an AI?
Yeah,
apart from clicking on the up.
Yeah, you just give it points. So it's like a computer game. It's like when it plays chess or something like. So basically, the human has to give it a weight. So you basically give it, well, the human is in the loop, but you basically give it we have a sentence and we know what the sentence should be. So the sentence, the cat is on the mat, and we know the word is mat, and then we just take it away from the computer and then have it come up with like guessed words. So basically just guesses any words and fills it in, and at some point it hits mat and then it gets 1 point. You know, if it gets the right word, it gets a point. And then you do that 1 billion times, and after a while, the computer will learn what word comes there because it gets more points. So it's basically like playing a computer game and rewarding it with points. And the higher the point, the better the answer was.
Okay, moving onwards. I'm conscious of the time. I don't want to be hanging because you have lectures to get to a little bit later. So we'll try and keep a little bit of urgency about all this. From Tom, can you integrate ChatGPT into the automatic production of documents, e.g. sample project plans? Also, can you provide it with a data set from Excel and get it to analyze it? Not really.
Yeah, there's stuff going on like that. It's a very good question, and it's nice. It's very specific. It's kind of I like that. I really like that question because it kind of shows like thinking how can this be used as a tool? You know, how can it make my life more productive, more better? So this is the way AI should be. And the first answer is maybe check if you're interested in that. OpenAI does start to have API integrations. So there's a big move around interfacing the technology with different applications. That's, for instance, happening with the Microsoft products, where the Microsoft products are being integrated more and more with ChatGPT, which means you can automatically create an email, automatically create maybe an introduction to a talk, or all this kind of stuff. So that could work. I'm not quite sure about project management, kind of planning. It might work. I mean, it's interesting to look at that. It's evolving so fast. There's so many areas that it's kind of being integrated in. And also it can use external references. So I would again invite you to kind of play with that, again, in a dialogue kind of fashion. I'm not quite sure if it allows the uploading of files yet. There might be a filter there, a problem, things that OpenAI still has to solve. But you can give it links, for instance. You can say, okay, on a certain website, extract certain information, or give me a summary of this website, give me a summary of this. So maybe if you kind of fool it a bit, if you put your Excel information onto a website, you point ChatGPT to that link, it might be able to help you with that.
Okay, great. My colleague down in another man in Engineers Ireland, Michael, asked this question. If an OpenAI is for profit, specifically with investment from Microsoft and other large companies, is there a danger that the answers will be geared towards benefiting the investors rather than the asker?
Absolutely. It's a for-profit company. These people want to make money, and most likely they will. They put a lot of money into it. 20 billion is a lot of cash. So you can also see that in the leadership of Microsoft already, that basically only talks about ChatGPT at this point. Google's leadership being completely scared because everybody thinks that Bing will now destroy Google search, and Google obviously has productivity tools such as Google Docs and Gmail and so forth. Google has a system now that was launched called BART, sometimes also referred to as BERT, similar kind of things, but it works just as nice as ChatGPT. So we're seeing a lot of competing products, and these are all companies that are obviously stock listed, for-profit companies, and at the end of the day, they'll want to make money. So that'll be the main interest, and that's something we as society have to be aware of, and policymakers have to. It's the same problem we have in social media. And social media policymakers, I think, are asleep at the helm. We see that in a lot of discussions in the U.S. Senate, where most of the political leadership doesn't even understand how data works. Social media companies can do whatever they want, and it can be the same with this. If we don't have governance, if we don't put pressure on politicians to create good policies, then this thing will just do whatever it wants.
The other aspect is the investment to actually train up a version of the model is significant. So they're talking about $1 billion cost at developing some sort of models. So I think that can only be expected.
Yeah. And there's so many things, the question marks, the environmental impact. how expensive it is to create these outputs, how this thing will actually make money, what the business models are around this. At the moment, there's a ChatGPT 4 version out that you have to pay. So there's a premium version or pro version in ChatGPT, but it's a very simple way. Just say, okay, you have to pay $20 a month to get better outputs. There's no real, it's all at the beginning at the moment, and it's and from an investment or business side, obviously fascinating.
There are quite a number of questions, but some of them comes under the title about concerns and security. There's 3 or 4 questions in there. I apologize, we can't do all the questions, but I'm conscious you want to finish shortly. There's been some concern in the security community that code generation like OpenAI Codex and GitHub Copilot could be used to generate more dangerous level of malware, and there's been reports by an Interpol on criminals using this.
Yeah, absolutely. I mean, the tool can't, like, in terms of language, it's been filtered a lot by human filters. So if you ask it to devise a plan to harm myself, or so, you know, if you kind of ask it for advice that is clearly harmful to yourself or to anyone else, ChatGPT did a great job to kind of filter that out. Apparently there's still some hacks to kind of get past those filters and get some kind of output that is harmful or questionable. But in the coding world, so ChatGPT is really good in creating code in all kinds of different languages and really creating very good code, even entire applications, games, smaller kind of text-based games. It's a fascinating kind of development if you're a developer, because it really creates it really makes things more productive. But like my example with the knife again, it's very easy to imagine that somebody goes in and creates a more sophisticated way of stealing passwords, or even worse. And that's something that's very hard to filter, because software lives on testing, iterations, lives on debugging. So it's very hard for a human filter to figure out what is actually this program going to be used for. So someone can come in, obviously, get a lot of code out of ChatGPT to save time instead of writing it themselves, and then use that as a kind of a template or as a framework to create more code, and then even to create a new virus or something that is malicious. But I don't think it's going to do anything that a human couldn't come up with. There's a discussion about that. It might become more advanced, and it might come up with ideas, new kind of viruses that would attack computer interfaces or computer infrastructures that a human couldn't have come up with. But I think at the moment it's more just supporting maybe criminal activities to move faster, to do things faster, to be quicker than other people that are creating proxies or some kind of security interfaces. So that's a big area, really worrying area, and I'm not quite sure how that's going to pan out, to be honest.
Yeah, we need to develop the tools, because you can't look inside the box necessarily and analyze it, is the problem. Yeah. Again, I have to mention a question from one of our own committee, so I'll be in trouble if I don't do this. Mike asks, what in your opinion is the most exciting application of ChatGPT 3.54 as it currently exists? Are there applications in medicine where AI can spot anomalies and scan? I think you've answered the one about the legal aspect in medicine, but for the first one.
Yeah, there's two things that for me personally, I'm fascinated about the use of the transformer models, the decoder encoders, how it's used for dialogue. That's a real nice thing to see, and to see it in action. So it's fascinating how well it works and how it's been implemented. So that's kind of a more kind of a nerdy computer science kind of answer. But on the bigger scale, which the CEO of OpenAI often talks about, is that OpenAI could potentially, ChatGPT could potentially be used to create new research, to create new knowledge, which is possible if we just look at ChatGPT, for instance, using all publications in a certain area in medicine or in environmental science, and then potentially even comes up with solutions or ideas of solutions. And that'll be an interesting thing to see, where research outcome, proper innovation can be created by such interfaces.
Okay, I'm doing my best for multitasking here, because we have got a whole bunch of questions. So I do apologize to the audience when we haven't got to a lot of these, but if there's anything when we have a look through, we'll perhaps respond directly to them. You'll have all the transcripts of the recording anyway, so you can go and listen through it.
It's great to see that there's so much interest in this. So that's obviously great.
One general question from Dee: what do you think is the biggest ethical challenge of these foundation model type systems?
Yeah, I see. Well, that's it's a big question now there. But for me, obviously, the big question mark is ethically is the system. The system is kind of very it doesn't really create any understanding of what impact the content has that it creates. So is it good or is it bad? Is it something that might have used images or text from an artist that now obviously is kind of in trouble because the AI creates something similar to that artist because it used all their artifacts. So something around, in my mind, it's a bit fuzzy, my answer. I understand that because it's such a big topic, but something around in my mind is how ChatGPT potentially can create issues around copyright, around creativity, around legal outcome, around all these kind of knowing if the output of the generated text is creating something positive and constructive for society or for the audience that it's giving it to, or if it creates something harmful. That's something humans have to assess. That's not something the machine can do, and that creates massive ethical problems.
Yeah, we have to go because you have to go. So I'll pack it out. Okay, thank you for your summary and all your excellent reflections, knowledgeable reflections. So I'll just stop there.
Thank you. That was lovely. Thank you very much.